Hello geometers and seekers of truth. In this short video we will talk about what's called the measure of an inscribed angle theorem, and this summarizes the last three examples that we did in this particular chapter, in this particular section. So the measure of an inscribed angle is always 1/2 the measure of the intercepted arc. So that means if I have a circle and then I inscribe some angle into here, right? So if I inscribe this angle into there, and let's say this is angle ABC, okay, then one thing that we can say is that the measure of angle B, right, that's the inscribed angle, is equal to 1/2 the measure of the intercepted arc. In this case, it's AC. Okay. And what we can say even further than that is that it doesn't really matter where this angle is this vertex is located, as long as it intercepts the same arc. So for example, even if I draw another angle here from A to this corner here, right, to C, because angle D still intercepts arc AC, we can still say that the measure of angle D is equal to 1/2 the measure of arc AC. Okay? So it doesn't matter where I place this angle, as long as it catches this arc, this arc at those same 2 points, the measure of this angle will always be 1/2 of the arc. We see 3 different examples of this in the last 3 problems that we worked on, and it just goes to illustrate that the same rule applies in all 3 cases. Alright, so let me give you an illustration here on Geogebra. So this is the arc that we're talking about here from this dot. Let's name that dot from D here to B. This arc right here is 122 degrees, and this is the intercepted angle, and this turns out to be 61 degrees. And it doesn't matter where I move this, right, as long as the angle intercepts those 2 points on that arc, and that arc is 122 degrees, that angle will always be exactly 1/2 the size of the arc. Okay, so even if I were to create a new angle, as long as I create this angle in such a way, right, that it intercepts that same arc, right, the measure of the angle remains exactly 1/2 the measure of the arc. Okay, so that's what this theorem is illustrating, and the proof of this theorem, you could go back to the previous 3 examples that we did to see how we go about it. There's 3 different cases to it, and each one of them is a little bit more complicated than the other. Okay, so I know this can be very challenging, and I know it can also be very tempting to just say, well, it must be 1/2. It looks like 1/2. It's tempting to make assumptions, but the real process of learning, of improving our thinking, is to make sure that we justify everything that we say with some solid reasoning. As always, thank you for watching. Keep working hard, and have a wonderful day.